Welcome back to Pharma-info with Shubhashish. Now today the topic is another synthesis, that is synthesis of procyclidine, right? Procyclidine, still we are we have not left the cholinergic system, right? We are still in the cholinergic system, but definitely we are at the verge of completing the cholinergic drugs. Okay, that means the synthesis of cholinergic drugs, not simply the structure, nomenclature and pharmacology, right? The synthesis, because few synthesis they have kept, the PCI members, okay, they have kept, right? So this is as for PCI for the UG syllabus and all, right? So synthesis of procyclidine. So procyclidine is basically a synthetic cholinergic blocker, right? Synthetic cholinergic blocker, and it belongs to the chemical category of amino alcohols, right? Amino alcohols, and preferentially given to alleviate the symptoms of Parkinsonism. Okay, Parkinsonism being an anticholinergic, it can be given to the patient who is suffering from Parkinsonism, and basically they are acting on, or they can work on rigidity associated with Parkinsonism, right? Okay, they can work well on rigidity, okay, moderate on akinesia, and least on tremor, right? All these things are found to be the the manifestations or the symptoms of Parkinsonism, right? Parkinson syndrome rather. Okay, so basically most of the anticholinergics, if they are being or they got the approval to be given to the patient who is suffering from Parkinsonism, they basically work on this particular rigidity, right? We have few more like bipyridine, trihexyphenidyl. These are also the example of anticholinergics given to the patient who is suffering from Parkinsonism, right? So without wasting much time in the uses and all, okay, let us just go to the structure, right? As I said that the structural classification in which procyclidine belongs is amino alcohols, right? Okay, so procyclidine, right? So cyclidine means definitely cyclic systems are there. Okay, so this is about one is aromatic, the other one is alicyclic, right? As I said, alcohol, you have to put alcohol, then CH2, CH2N, and here you have to again cyclidine, idine. This particular thing should give you the clue of what? A 5-membered ring system devoid of pi electrons. I have not kept not even a single pi electrons here. So that is why this is pyrrolidine, right? So you have to do the alteration, okay? Just spend some time with this particular drug. That means the name and all, and the structure and all, and just relate, okay? Make a big word, right? Okay, so with that you can just unfold the mystery lies in the name itself, right? Chalo. So this is about your procyclidine. We are done with the structure of procyclidine, right? Okay, now coming to the IUPAC naming and all, okay? Now in order to frame the IUPAC naming, first and foremost we need to see that which one has to be considered as a parent, right? So here definitely not the nitrogen, rather the hydroxyl, okay, hydroxyl, because the chemical name itself suggests it's an amino alcohol, right? So definitely what we are expecting, this is found to be the parent, right? So this is found to be the parent. The parent is nothing but what? The parent is nothing but propanol or propanol basically. So it is the propanol that is holding what? Position 1, 2 and 3. Position 1 is holding what? Phenyl. The same first position is holding another cyclohexyl. And then position 3 is holding what? Pyrrolidinyl, right? Pyrrolidinyl, right? Because it is acting as a substituent. So, what can be done? So, this is 3 holding pyrrolidinyl, 1 phenyl, 1 cyclohexyl, propan, 1 all, right? Or prop 1 all, anything, right? Okay. So, this is the IUPAC naming and all. So, how it goes? 3, complete. What is there in 3? Position 1, come to position 1. You can just initiate the process with position 1 as well. So 1 phenyl, 1 cyclohexyl, 3 pyrrolidinyl. Then what is left? Propan, 1 all. So this is how the IUPAC name goes, right? Okay. Now we need to see how this can be made, how this can be manufactured, rather. Okay. So how this can be manufactured? So for the purpose of making this particular thing and all, so what they observe that methylenic moieties are there, multiple methylenic moieties are there. So if multiple methylenic moieties are there, you have to incorporate the methane. That means you need to extend the chain length. You need to lengthen the chain, right? Hydrocarbon chain. So how the methylenic moiety can be incorporated? This should come. This is bound to be the first thing that should come in your mind. That is there any way by which we can incorporate methylenic moiety? Is there any way by which we can keep increasing the methylenic moiety in a particular hydrocarbon chain? Yes, there is a way, right? The way is paraformaldehyde, that is CH2OX. It is the paraformaldehyde that is quite often being used for the purpose of increasing the chain length. And the chain of what? Chain of hydrocarbon. Chain of hydrocarbon. Okay. So this is found to be the one that should be introduced here, right? Okay. Now let us see. That should be introduced here, right? So how it goes? Let's see how it goes, how the reaction goes. So first and foremost, we have to start the process with, because we have here in the left side we have two bulky ring system. One is found to be aromatic, the other one is found to be alicyclic, right? Okay. So let us just incorporate the first one. Deal with the first one, right? The first one is phenyl, right? To that phenyl I wish to put, and to that phenyl the carbon is there, and to that carbon one oxygen is there, right? This particular oxygen, if it is found to be in the ketonic form, that can be reduced to CHOH. That is true, right? If that is the thing, at the same time, the other thing that can be done is, if we do the if we bring Grignard reagent, then also we can convert the C double bond O into CHOH. That can also be done. At the same time, with that particular Grignard reagent, we can utilize the other half of Grignard reagent in inserting what? The other alicyclic system or other bulky ring, right? Okay. So that means we'll just make it like this: CHCOCH3. So this is found to be the first starting material. As I said, this CH3, next to it another CH2 is there. No longer it will be in the form of CH3 when we are going to make this procyclidine, right? Okay. So definitely next to it another methylenic moiety has to be incorporated. So that is why we just now came to know that it is the paraformaldehyde that will serve the purpose, right? So that will serve the purpose. Okay. So what next? After this CH2, so we have one CH2, we have another CH2. That is connected to what? That is connected to pyrrolidine. So straightway N pyrrolidine. So these are the three essential starting materials that we have with us. So one is found to be acetophenone, the other one is found to be paraformaldehyde, and the third one is found to be pyrrolidine. So these three, okay, how they will interact, right? Let's see how they will interact, right? Okay. So definitely we are expecting what the first intermediate should form, right? So the first intermediate says that I should look like this, right? So we have got something like this. The next step is what? As I said, that this C double bond O has to be converted to CHOH, and for that very need we have to bring what? Grignard reagent. Why? Because it is the Grignard reagent that will bring the other bulky ring with it, right? The other bulky ring, right? Okay. So that means the other bulky ring is found to be alicyclic, that means cyclohexane, but we are not using cyclohexane here because we know the tricks by which benzene can be converted into cyclohexane, right? So that is why instead of taking cyclohexane, we'll just deal the process with phenyl. So here the reagent that we are going to introduce is phenyl magnesium bromide, right? So this is the first intermediate that will react with phenyl magnesium bromide. So what can be expected? Okay, let me just do one thing. Okay, now we'll do here. What can be expected here? So here we can expect we are almost done, right? We are close to procyclidine. Phenyl, right? Almost done. Only thing is that we need to remove the pi bonds, right? Nothing else. Only we need to remove the pi bonds, okay, from this particular ring system, right? Okay. Now let me just rub it off this one. Let me just rub it off. So here we know that it is the platinum oxide, right? It is the platinum oxide that is meant for hydrogenation. It is the platinum oxide that is meant for hydrogenation, right? So that means what has to be brought here? H2PTO. It is the H2PTO, that is platinum oxide, that will convert one of the phenyl to cyclohexyl, and we have got our desired compound, that is nothing but 3-pyrrolidinyl, 1 phenyl, 1 cyclohexyl, propan, 1 ol. That's all, right? So this is how we can make what? This is how we can make the synthesis of, we can make procyclidine as an anticholinergic. Hope you have enjoyed the session. If you like this video, then please don't forget to press the like button, and please do subscribe my channel. At the same time, please share amongst the students and all, amongst your friends, so that they also come to know, yes, something is going on. And please put your valuable comments in the comment box. Thank you for your patience hearing. Thank you.